Hi everyone. I think we're starting to reach the 1 o'clock. See if there's, yep, people are still joining. So I think we're past 1 precisely. So let's start. Um, Hi everyone. My name is Johan Westerdahl. I normally speak in regards to workstation, but today we're going to have a brief walkthrough of the new addition to the ThinkReality family, the A3. After the presentation, Marcus at Varjo will show their latest products within AR/VR. Varjo is an extended partner to Lenovo. And with that said, let's kick off with a film.
Everything evolves. Our planet, our lives, especially how we connect. Times. Others, they need it. Think reality as a catalyst, pushing you past, evolving your workforce right now. This is the evolution of collaborating, where meetings are immersive, expanding past what we've always done, efficiently, securely, wherever you are. This is the evolution of training, where employees learn new skills in safe settings, interactive, repeatable, with measurable results. This is the evolution of leadership. Experts guide your newest employees seamlessly with ease. Continents. Scalable, immersive, enterprise-grade solutions. Not when, but now. This is the evolution of working smart together. Lenovo ThinkReality.
Great. I hope everyone could hear the video. I like to explain in short what the ThinkReality is. It's actually way more than just a pair of sunglasses. It's a suite of solution that includes a scalable software platform, as you see on the screen right now, which gives our customers the ability to manage applications and their devices through a single interface. The ThinkReality platform do not only support Lenovo, other products such as Varjo is fully supported. The ThinkReality also includes a lineup of enterprise-ready hardware, like the A3 we're going to talk about today, and A6. All of this is supported through the Lenovo Global Service Organization with premier support, with service offerings specifically tailored to support the AR and VR solutions. So the A3 is a commercial enterprise head-mount display, which fits the user like a regular pair of sunglasses. A quick deep dive into the A3 headset. The A3 headset is a tethered headset, and I'll talk about what it tethers to in just a bit. The headset is powered by a Snapdragon XR1 chipset. In addition, we have a 8 megapixel camera in the front for doing remote expert work or just to record a workflow or record a step-by-step manual. We also have a microphone and speakers. You can have a conversation with your remote expert, or you can record the step-by-step video with audio instructions. The standard front frame of the A3 can be removed and switched out for the industrial front cover, which provide additional side-eye protection so work can be done efficiently. and proactively, even in environments where enhanced safety is required. The headset weight only 130 grams, so they're super light. And this headset has been designed for enterprise use, and they have been drop tested. The IP54 standard passed. The ANSI impact drop ball test, as you can see here, is the drop into concrete. And here's a steel ball drop test on the industrial front cover. And the headset comes with a fit kit. Faces and heads are very different among people. So the headset comes with 3 different nose pieces and 3 different temple ends, depending on size or shapes of the user's head. If you need glasses, you need a prescription insert, which we will enable to order through our website, or you can take the insert and your prescription to your local optician, and they will provide glasses for you. On this slide, you can also see the industrial front frame kit in the front here. So the A3 comes in basically 2 versions. When you tether the A3 to a mobile workstation via USB-C, the A3 enables a whole new way to work. It allows you to position up to 5 virtual monitors that only you, the user, can see. So you can position them and manage these through your virtual, basically your Windows toolset. And this is the PC edition. What I would call the true AR edition is the industrial version. When the A3 tethers to a G100 Motorola phone, which we will basically bundle with the industrial version, the headset can be managed and provisioned through your ThinkReality platform to run certified solutions and applications such as remote expert workforce, support training modules, 3D visualization, or you can just participate in online collaboration and such. We developed these headset with a couple of different use cases in mind, and it's probably the most versatile headset on the market. And I explained what I mean with that. So this is the PC edition. We envisioned this product a year ago when we still had road warriors, people constantly on the run, basically on trains, planes, and so forth, but in need of privacy and often in need of greater or more displays. The A3 basically solves that space issue on the train and plane and the privacy. But the most relevant right now would be the home or work from home user. It's probably the most growing use group. Most of the work from home users do not have space for 2 or 3 monitors on their kitchen table or basically in their apartment or houses. The A3 is very, very easy to use and will basically sort the space issue. So the workspace can be increased and the productivity as well. The open office users, I think these will come back soon. And there is still a great use case with a privacy for such as HR or financial department that work with classified data. The A3 gives them the privacy they need and added displays. So this is how the headset basically works, the PC edition.
Introducing the ThinkReality A3, the most versatile enterprise.
Then we have the industrial edition, and when you tether the A3 to a G100 Motorola phone, you get the true AR edition experience. Sorry, in the industrial edition, the phone gives you as well 5G cellular connectivity, which is great for having on-screen keyboard and super handy for like entering passwords or chats and so forth. The remote experts case is basically technicians out in the field that can be easily guided from a more senior remote technicians, which will be minimizing the downtime. Workflow, you get the step-by-step instruction right in front of your eyes. It's great for training or just to keep consistent quality or to do audits. The virtualization people, we need to basically virtualize anything that doesn't fit in your pocket. You can easily have a jet engine in your pocket and right in front of your eyes with a A3. And this is basically the A3 in short. And I think we have some minutes to address the Varjo. So let's see if Marcus is on the call.
Yes, I'm here.
Perfect.
So, good afternoon, everyone. My name is Marcus Heinonen from Varjo Technologies, and let me just open up. So, for those of you who haven't heard from us before, just a brief background. Varjo is right now a 5-year-old company funded by former Nokia Microsoft engineers, the same people that started the HoloLens project back 10 years ago, that was still under Nokia back then. They decided to fund a company after what happened to Microsoft in Finland when they decided to shut down all the operations. And this group then started Varjo and wanted to do the most realistic virtual and mixed reality technologies. And we decided to do the mixed reality completely other way around than what Microsoft and HoloLens was doing. So instead of doing it in a optical see-through device, similar to the A3 that you just saw, where you can see the real world through your own eyes, we decided to do a VR headset with video cameras in front of it. And in that way, you can see the real world through the video pass-through, and everything is then shown on those VR displays in front of your eyes. And in that way, we have full control of every pixel, and we can completely modify the real world and combine the physical and the virtual. Since then, we've grown to roughly 150 people, most of us located here in Helsinki, where all the R&D happens. But then we also have offices in Washington, D.C. and in the biggest markets in Europe. And we are the second most funded company in this space, so right after Magic Leap. And there are 3 distinct focus areas where we are right now seeing most traction. So first of all, anything that has to do with training, so pilot training or astronaut training. Boeing is training all of their astronauts for the Starliner program using our technology. And the reason they're using our technology is the resolution. So our headsets are capable of showing the virtual objects as clearly as you see them in real life. So if you're sitting in a cockpit, you can read all the dials, see all the details just like you would in real life. And for the same reason, we are very heavily used in the design and engineering space. So when it comes to creating anything new, you can visualize that in 3D and see all the smallest details like you would in real life. So if you're designing a car, you can see the stitching on the car seats or all the details in the dashboards. Then that has been completely impossible with any other VR or XR technologies before, because the lower fidelity of those devices have made it impossible to see the details. And there are 4 areas where we are different from all the other devices out there on the market. So first of all is the human eye resolution, and I just mentioned the ability to see the details like you see them in real life. And this makes it possible to train realistically for pilot training or any kind of operator training. So the nuclear power plant here in Finland, Fortum, they're training all of their operators now in virtual reality. Instead of using physical mock-ups of that control room, they can now do it all of that in virtual reality, and they can also simulate any kind of emergency scenarios that would be impossible to do otherwise, because you don't want to set the real place in fire, but all of that is possible to simulate in virtual reality. Then we also have the eye tracking technology, and this enables unique research scenarios, but also you can study the user's behavior inside the VR simulation. So you can get interesting performance analytics out of the training situation. So for example, US Air Force have a use case where their pilot is sitting in a cockpit and they have an emergency scenario there, and they then get a checklist of things that they have to look through inside the simulation. Now with the eye tracking, they can automate the whole training process. So they can verify that the pilot had looked at all the right things inside the simulation, and then afterwards get a report with a timestamp when the person looked at all the right things inside the simulation. And in this way, you don't even need an instructor next to the person to verify that the training was done in the right way. Then we also have the video pass-through mixed reality that I mentioned in the very beginning, and this was the foundation for the company. So to create a pass-through mixed reality experience. And the reason why this is superior in those cases where you really need to have the clear visuals is that you have full control of every pixel, and you can make so realistic digital objects that you don't even distinguish between what's real and what's not. And then the third part is the hand tracking. So you can interact with digital objects just by using your own hands. And we have two different products. The other one is the device where you can see through the headset with the cameras, and then the other one is just a pure VR headset without any cameras in front of it. And when I say the human eye resolution, this is what we mean. So the resolution is roughly 5 times higher than any of the closest competitors in VR. So you can see all the details like you would in real life. For example, when Kia Motors is designing their cars, they say that they have to be able to see the individual paint flakes on top of the car on that painting, and that's completely impossible to do with any other type of technology. And with the various headsets, they can see all that like they would in real life. And when I said and compare it to the optical see-through devices, they have a completely different use cases. So they're lightweight, they are mobile, just as you saw in the previous presentation. You can wear them when you walk around on the production plant, but various devices are nothing like that. So they're feathered, they need a high-end PC to render the visuals. So they're suited for use cases where in a stationary environment, in a defined room, but they also are capable of showing that very high resolution visuals. So the images are not transparent in any way. You have the full field of view of the headset, and the virtual objects are also behaving like a physical object would. So here's one example of a Volvo car that's placed in our office, and so it's a physical environment around, but the car is virtual. And you can look at the cars on top of the car, how the car is reflecting the real light when we turn on and off the lights in this video. So the virtual car is reflecting the real light in real time. So when the real environment is changing, the virtual objects is also changing according to that, because we can identify the light sources with the video cameras that are in the headset. You can then overlay that on top of the model. And then you can also see all the details like you would inside the car as well, just like in a real physical car. And you can also bring your own hands to the view, and they can be occluded from the virtual content. Then it's also possible to do collaborative design reviews. And this is what Kia is now doing when it's impossible to travel and it's also very expensive to travel. Before it took them 4 days to do the design review that they can now do just in 1 hour. So in this example, we are in a Frankfurt office, so it's a real physical place, and the colleagues from Korean office have joined in as avatars to the same scene. So everybody's seeing the same model, updating in real time, and the design review can be now done in just 1 hour that used to take 4 days. And this is using the Autodesk VRED software that has the collaboration feature integrated. Then another example is just to use your favorite CAD tools. In this case, this is Rhino. So there's a live link to Rhino. You can make any edits. You can study the models. You can spot some errors that would have otherwise go unnoticed when you can visualize them in 3D environment. And this could be also done in a collaborative way that your colleague would be in the same environment physically with you, and you could see the same model updating in real time. Then it's also possible to use your favorite 2D monitors inside the mixed reality. So you can mirror your desktop view into the real world. So in this way, you don't have to take out the headset when you're making your designs. You can use, in this case, the Unity editor at the same time when you're seeing those changes made in the real world. Then here's an example of using the Autodesk VRED that you saw before in the Kia example. And of course, you have all the tools available that you can use in VRED in the 2D interface as well. You can change the colors, make any kind of edits that you want, but now you can do them in mixed reality. And in the same way, you can use the 2D application to load the model to make any changes in that virtual screen. And then when we talk about the other use cases, the training side, you can this is an example of a cockpit simulator where you can see your hands. So this is just a lightweight setup with a pure VR. So everything is virtual. You could deploy it anywhere. There's no additional physical equipment in it. But then you can use that same hand tracking in mixed reality as well. So you can interact with virtual objects just by using your own hands in mixed reality. And then probably the most interesting use case when it comes to the training side is the mixed reality trainer. So when you combine something physical with the virtual world, so you can get the best of both worlds. You can get a lightweight setup, but you can get the immersion that you get from a full flight simulator. And here's an example of a Bohemia Interactive's Apache helicopter simulator. And in this case, the user can see the dashboards in front of him through the video feed. You can see the joystick, you can see your own hands, and then only the outsides are then simulated. So in this way, you can combine some of the physical elements that you want to have there for the most realistic experience, and then have only the outsides simulated. And for that reason, there was also the first European Union Aviation Safety Agency, EASA, has certified the first virtual reality trainer that can be used to credit for up to 10 to 20 flight hours using the VR devices. Because right now the fidelity is so high that you can train so realistically that it's almost like flying the real thing. Then you can also make the training more collaborative, and you can be in a fully virtual environment, train any kind of safety or emergency scenario, and see your colleagues in that same environment through the video feed, and then operate the virtual environment.
Hey, jag fick till flight-drivern.
And that was it what I wanted to share. I don't know if you have still some time for a few questions, if there are any.
Ja, jamen.
Sorry, was there?
If anyone has questions, you are free to contact us or by email or phone or via the chat. But I think we are 6 minutes past our time. Okay, thank you, everyone.
All right, thank you. Bye-bye.